Testing, testing. Hello. What we're going to do now is we're going to play around with this multiplexer, the 2 to 1. Notice it's written as a ratio 2 to 1. It means you have two inputs, get multiplexed or plexed into one output. And we have some command or control system that will direct the traffic. Now imagine I want to make a box or some sort of box where the output was always just the opposite of the input based on commands. What I could do with this, if it let me modify it, is the following. I will go here. Well, it won't let me do it now. I have to go to another box. What I could do is probably, well, let's do it. I'm going to use that as my baseline. Project, load library, Logisim, bring in my mux. There it is. Use it in a circuit. What I'm going to do is take this as my input, and I want that output here to always be opposite of this input. So I'll drag a line, drop it in there. Now it's a multiplexer though. It needs a command. So what I'm going to do is I'm going to take this wire here. I'm going to make the bottom channel, channel 1, always the opposite of the first channel. Channel 0, channel 1. I'll always make them opposite each other. How do I do that? I go into my gates, grab a NOT gate, and tie it right in like this. So notice these two wires. If I simulate it, the two inputs will always be opposite one another. So what I'll do here in my control, plug that in. Now in my simulation, but if I say channel 0, watch this. Input's a 1, output's a 1. Input's a 0. Notice the input and output exactly matches. If I say turn this into a 1, notice the input and output are now opposite one another. So what have we done? We turned around and we had taken a device, this device, a multiplexer, and reconfigured it so that it actually works as this newer device here. So what I could do is delete this, and I should give these things names. I'll call this one invert. I'll call this one in. I'll call this one, by one I mean pins, I'll call this pin out. Now I have this new chip. If I put this in a box, I now have a new chip. So let's put that in a box, save as my inverter. So now I go project, load a library, find my inverter. Now notice I have one pin coming in, top, bottom, side, and now I have the ability Control C, Control V, so I don't have to keep, whoops. This will work the same way. Now it's the opposite because I told it invert. Do not invert, and it's not inverting. What does this look like internally? Internally, let's get rid of this. I actually have this multiplexer, but the multiplexer, remember this input is now dragged over to here. So this is my new simple. Notice I put in quotes, if I could spell the word simple. Simple controlled inverter. This is my input. 1, 1, 0, 0. Simulators are so great. Look at that. You can actually see the circuit working. Invert. And now it's the opposite. And you can almost see the flow going the opposite way in this direction. As the semester goes on, we'll be building more and more circuits out of smaller circuits, making things much more complex.